Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is a Mechanics for October-November 2023, and the code is 9709/41. So let's move on to question number 1. For question number 1, a particle of mass 1.6 kg is projected with a speed of 20 meters per second up a line of greatest slope of a smooth plane inclined at alpha to the horizontal, where tangent alpha is 3/4. Now use an energy method to calculate the distance the particle moves up the plane before coming to instantaneous rest. Okay, so now basically this is the diagram. Let's say here is alpha. This is the particle. Okay, the u is 20, so u equals to 20 meter per second. And then the tangent alpha is given as 3/4. So the m here is 1.6 kilograms. Okay, so now before it comes to the instantaneous rest, that means v equals to 0. Okay, we need to find when v equals to 0, what is the distance. So it means that here, okay, distance and v equals to 0. Okay, so from here, I will be referring to the conservation of energy, of mechanical energy. So this is the energy method, right? So according to this principle, right, initial mechanical energy, ME, equals to final mechanical energy. So this is ME. Right. So now the initial mechanical energy is basically initial kinetic energy plus initial gravitational potential energy. Then for final, ME will be just change to initial to final. Okay. Alright, so now the initial kinetic energy or kinetic energy is basically half mu squared. Okay, then the PE, gravitational potential energy, is mgh. So now from here, initial kinetic energy is m, or half. The m is 1.6. Then the u is 20, so 20 squared, plus initial gravitational potential energy, m is 1.6, g is 10. At first, it is 0. So for the final KE, it will be half 1.6. So the V is 0 plus 1.6 is the M. G is H. Okay, what is the H here? Oh, sorry, G is 10. The H is basically counted as vertical height. This is a H. So from here, right? So now, when you refer to this triangle, okay, to get a H, to connect the H, alpha, and D, obviously sine alpha is H over D. Okay, so from here I know that sine alpha is H over D. And now I need to find what is my H. So therefore my H is D sine alpha. Okay, then from here I will write D sine alpha according to the triangle. So then now when you calculate the left hand side, half times 1.6 times 20 squared, that is 320. Then the next value is 0. And then the first value on the right side is 0. So for the right hand side, I will be getting 1.6 times 10, I'll get 16. The D remains. Now sine alpha, okay, look at the tangent alpha here. So for tangent alpha, that is 3/4. That means it's opposite over adjacent. So the hypotenuse is going to be square root of 3 squared plus 4 squared. That is 5. Okay, so now our sine alpha is going to be opposite over hypotenuse. So opposite is 3. Hypotenuse is 5. Okay, then from here the right hand side is going to be 48 over 5d. Then now my d is going to be 320 times 5 over 48. And this is going to be 100 over 3. Okay, so that's the d value, the distance. And the unit is meters. Okay, now for question number 2, a particle of mass 2.4 kilograms is held in equilibrium by 2 light inextensible strings, one of which is attached to a point A and the other attached to a point B. The strings makes angles of 35 degrees and 40 degrees with the horizontal. So see the diagram. Find the tension in each of the 2 strings. So from here, I will let this be tension 1 and tension 2. Okay, so now from here, the keyword is equilibrium. So when it is in equilibrium means that this is not moving. So now I need to resolve. Alright, when you resolve, you have to resolve vertically or horizontally. Okay, so now from here, for the 2.4 kilograms, the mass is going to be 2.4 grams. Alright, the weight is 2.4 grams. So from here, 2.4 g, sorry, 2.4 g, because the weight is mg. So now I resolve horizontally. So when you resolve this downwards, okay, so I will write T2 cos 40 degrees because I'm referring to the given angle here. Then since the T2 is towards right side, then the T1 is towards left side. So it will be balanced. Then it will be T1 cos 35 degrees. So from here, I can get my T1 as, I can get my T2 as T1 cos 35 degrees over cos 40 degrees. Okay, I let this be the first equation. Now when I resolve vertically, I assume vertically up is, upwards is positive. So now I resolve the T1 upwards. So I will get T1 sine 35 degrees because we are not using this angle, but I'm using alternate angle. Therefore it is sine. And when I resolve the T2 upwards, it will be in the same direction, which is upwards. So therefore it is plus T2 sine 40 degrees, and it will be balanced with the weight here, that is 2.4 g. This is my second equation. So now I substitute first equation into second equation. So my T1 sine 35 degrees plus T2 sine 40. So the T2 will be replaced by the T1 cos 35 degrees over cos 40 degrees. Then it will be 2.4. The G is 10. Right, so the left hand side it will be 1.26093 T1 equals to right hand side is 24. Then from here your T1 is 24 over 1.26093. Then this is going to be 19.034 and I will be getting 19.0 newtons. So that's the T1. Okay, or probably you can write T2 or T1. T2 as TB. Okay, so this is TB, this is TA. So T2 is TB, this is TA. Okay, so we have solved for the TA. Now for TB, so just from the first equation, TB is TA. Okay, so I will write 19.034 multiply with cos 35 degrees divided by cos 40 degrees. So this is going to be 20.4 newtons. So that's the solution of this question number 1. Okay. Now for this is question number 2. Okay, question number 2. So now for question number 3, the diagram shows the velocity time graph for the motion of a bus. The bus starts from rest here, accelerates uniformly for 8 seconds until it reaches a speed of 12.6 meters per second. The bus maintains this speed for 40 seconds. That means here is 40. It then decelerates uniformly in 2 stages. Between 48 and 62 seconds, the bus decelerates at a meter per second. And okay, this is a meter per second. And between 62 and 70 seconds, it decelerates at 2a. So this is 2a meter per second squared until coming to rest. Okay, this is meter per second squared. Now A, find the distance covered by the bus in the first 8 seconds. So we need to find this. What is the distance? Alright, so for your information, distance, let S be distance. Okay, S equals to UT. So we know that it is going to be half. The U is given, which is 12.6. Right. Or I would say that distance is U times T is basically area under the curve. So here is 12.6 and then this is 8. Alright, so 12.6 times 8. Then here is going to be 50.4 meters. So that's the distance of the first 8 seconds. Okay, now B, find the value of A. So the A here, right, I would say that when you consider in general, so here, this is 12.6. Right? So now I will consider up to t equals to 70. So that means because from here I will say that this is a u and then this is a v equals to 0. Right? So now I will consider this will be 22 seconds. Okay? So using formula v equals to u plus at. So v equals to 0 and then the u is 12.6. So here 0 equals to 12.6 plus, now the a remains, but then the time, the t is 62 minus 48. So here, okay, and one more thing is you have to be careful because it's mentioned decelerates. That means here is actually negative, right? That's why when you look at the gradients here, it's negative, right? The acceleration is negative a and acceleration is negative 2a. So I will write negative a, then the timing is 62, the time is 62 minus 48. Okay, which is here. This is 62 minus 48. And then the other one is minus 2a. Okay, and then the time is 70 minus 62. Alright, so from here you get 0 equals to 12.6. So 62 minus 48 is basically 14. So here minus 14a. And then 70 minus 62 is 8. So 8 times minus 2a is minus 16a. Okay, so the total a here will be 30. So 30a is 12.6. Therefore, your a is 12.6 over 30. And then you will be getting 0.42. So that's the A value. Okay, now C, find the average speed for the bus for the whole journey. So the average speed means that we need to find the total distance. Alright, so now I need to calculate the total distance first. So now, when you look at the diagram, okay, we need to know what is this V. Okay, so what is this V1? Let's say for example. Okay, then from here, I will write when t equals to 62, what's my V1? So now I will use the same formula as just now. So V equals to U plus AT. So at t equals to 62 seconds, let V equals to V1. So now I will get V1 equals to, okay, look at the diagram. So I just consider this distance, this time, alright? So my U is 12.6. This is my V1. So here I will get U is 12.6, and then my A already found just now. My A is 0.42, but then based on the diagram, the acceleration is negative A. That means it's going to be negative 0.42. Okay, so here I will write plus negative 0.42, and then the timing. Okay, what is the, not timing, the time spent. So how much time has spent? So it is 62 minus 48. So 62 minus 48 from the previous calculation, that is 14. So you multiply with 14. Okay, then from here you will be getting 6.72. So I know that this is 6.72. So the distance is basically the area under the curve. So now I have to find four distances. So which is first, second, third, and fourth. Okay, so now just find the area under the curve. So total distance. So the first one I have found 50.4 just now. See here, 50.4. Plus, okay, so for the second distance, that is the area of this rectangle. Okay, that means now I know that it is 40, and the length, the height here is 12.6. So it will be 40 times 12.6. Right. So here I will just write plus 40 times 12.6. And then the next one is going to be trapezium. Okay, trapezium. Now for information, area of the trapezium, let's say here A, this is B, this is C. So the area is half of sum for the parallel sides, so A plus B, and then the height. So half of A plus B times C. So that means now here, this is 12.6. Okay, and this side is 6.72. And then you multiply with the distance, 62 minus 48. Right, so now I will just write half of 12.6 plus 6.72, then you multiply with 14. Okay, then you plus last area. This distance here is 8, and the height is 6.72. So I will write half times 6.72 multiply with 8. So that means you will be getting 716.52. Okay, so the average speed that is total distance over total time spent. That will be 716.52 divided by the time. So the total time based on the graph is 70 seconds. Okay, so here over 70. Then you will be getting 10.236 meter per second. And now I round up the value to 3 significant figures. That will be 10.2 meter per second. So that's the solution of this question. Okay, now question number 4. Two particles P and Q of masses 6 kilograms and 2 kilograms respectively lie at rest 12.5 meters apart on a rough horizontal plane. The coefficient of friction between each particle and the plane is 0.4. Particle P is projected towards Q with speed 20 meters per second. Now A, show that the speed of P immediately before the collision with Q is 10 square root 3 meter per second. Okay, so that means this is your P, here is your Q, right? So the distance is 12.5 meters. So now this is a plane, and this is rough plane. So from here, I will get the frictional force 0.4 R, because our frictional force is mu R. The mu is 0.4. Okay, now towards the Q, this is your U. UP is 20 meter per second. Now MP, okay, now show that the speed of P immediately before the collision with Q is this. So your MP is 6 kilograms, your MQ is 2 kilograms. Alright, so from here, I will say at point P, or at particle P, okay, I will just write particle P. We refer to F equals to ma, the Newton's second law. So now your F is negative 0.4 R, okay, because the particle is moving to right side towards the Q. Then the FR is towards the left side. Then here is going to be 6A. Then from here, my R is mg. Okay, so the m is 6 because at the point P, the g is 10. Therefore, the R is 60. So here I will write negative 0.4 times 60 equals to 6A. So now I need to find the A first. Now my A is going to be negative 0.4 times 60 over 6. Then this is going to be negative 4. Okay, now to get the speed, okay, the speed of P before the collision, that is my final speed. So I will use V squared equals to U squared plus 2AS, because all the information are given. So here V squared is your U squared, your U is 20, so it will be 20 squared plus 2A is minus 4, the S is 12.5. Okay, then this is going to be 300. So now when V squared is 300, then your V is square root of 300. So then I will be getting 10 square root 3. So that is your V value. So we have shown this. Okay, now in the collision, P and Q coalesce to form particle R. So B, find the loss of kinetic energy due to the collision. Okay, so now before the collision, okay, This is a P. UP is 20 meter per second. Then this is a Q. The UQ is 0. Okay, so after the collision sticks together, okay, or form the R. This is before collision. This is after. Okay, so now I need to know what is my V here. What is my V1 to get the loss of kinetic energy. So now using the momentum, okay, linear momentum principles. So at first, right now here you have to be careful. We are no longer using, you see, this one is the speed of P immediately before the collision. That means now I cannot refer to the UP anymore. This one I should use VP. Okay, VP is 10 square root 3. Alright, so here is going to be MPVP plus MQ UQ equals to MR V1. Okay, so your MP is 6, VP is 10 square root 3. Then the MQ is 2, because if you remember, here MQ is 2, MP is 6, then it is not moving, so it's 0. The MR is the total. Total, it becomes 6 plus 2, then V1. Then from here, I will get 60 square root 3 equals to 8 V1. Therefore, your V1 is 60 square root 3 over 8. That is 15 over 2 square root 3. Okay, so I know that after collision, the particle R will move with 15 over 2 square root 3 meter per second. Now, the question asking for a loss of kinetic energy. So now, loss of kinetic energy, that is, because of loss means that it will be initial kinetic energy minus final kinetic energy. Okay, so for initial kinetic energy, it will be half M is 6, because initially the P is moving, the Q is not moving. So then the V is the VP, 10 square root 3. Okay, but final kinetic energy is basically caused by the R. So that means that is going to be half 6 plus 2, because both particles collide. Then the V is 15 over 2 square root 3. Okay, then from here you will be getting 900 minus 675. So at last you will be getting 225 joule. So that is the loss of kinetic energy. Okay, now next part. The coefficient of friction between R and the plane is 0.4. Find the distance traveled by R before coming to rest. Alright, so from here, this is the R, and we know that the V1 is 15 over 2 square root 3. And this plane is rough. So I know that you will be getting FR. Right, so now your mu is 0.4. Okay, so before coming to rest, that means when it reaches here, V2 is 0. What is the D? Okay, so now I need to find out what is my FR first. So my FR is mu times R. So what is my R here? Now, see, this is the R prime. Okay, So then I will write it is mu r prime. So it will be 0.4. My r prime is due to the mass. So this is 6 plus 2 kg. Therefore, it will be 8. So here I will write 6 plus 2 g. Okay, that is my r prime. So then from here, when you calculate the values, this is going to be 0.4 times 8 times 10. So it will be 32. So now, to get the distance, I need to find what is my A. Okay, so then I will just write F equals to MA. So then from here, FR, okay, FR is 32. The M now is 8 times A. Therefore, my A is minus 4. Okay, then now to get the D, the distance, what to do is we refer to the formula, because now from the diagram I have V1, I have V2, then I have found the A. Then I can apply formula of V squared equals to U squared plus 2AS. So your V is 0, your U is 15 over 2 square root 3. Okay, plus 2, A is minus 4 that we have found here. Multiply with S. Then from here, you will be getting 0 equals to 675 over 4 minus 8S. So then 8S is 675 over 4. At last, your S is 675 over 4 times 1 over 8. Therefore, you will be getting 21.09375, which is 21.1 meters. So that's the distance traveled. Okay, so done for this question. Now, next question, number 5. The diagram shows a particle A of mass 1.2 kg, which is here, which lies on the plane inclined at an angle of 40 degrees to the horizontal, and particle B with mass 1.6 kg, which lies on the plane with inclined at angle 50 degrees to the horizontal. Okay, then both particles are connected by a light inextensible string, which passes over a small smooth pulley P fixed at the top of the planes. The parts AP and BP of the string are taut and parallel to the lines of greater slope of the respective planes. The two planes are rough. Okay, so this one is important. This is rough, with the same coefficient of friction mu between the particles and the planes. Now, find the value of mu for which the system is in limiting equilibrium. So, limiting equilibrium means that it is not moving, right? So, from here, it's expected the B will move down because of heavier, right, greater mass. Then the A will be moving up. Okay, so now A equals to 0. Okay, so now, because they are not moving, limiting equilibrium means that just about to move. So if not moving, definitely the A equals to 0. Okay, this will be A. Then from here, I will say that for the 1.6 kg, so this is the weight, 1.6 g, and this is the R. Okay, RB. Then now, when it is moving, it will be expected to move down. Okay, so from here, definitely your frictional force will be moving up. This is your frictional force of the B. Then for the A, it's the same case. It will be the mass 1.2, the weight is 1.2 gram going down. Then the RA, it is perpendicular to the plane, and I will expect it moves up. that means your frictional force will be moving down. So this is your FRA. Okay, so now when we resolve, so for the A, okay, if I resolve parallel to the plane, now for your information, okay, when I draw properly, this is 1.2 G. When I resolve parallel to the x-axis, parallel to the plane, I'm going to use this angle, but then this angle is not given. So to use a alternate angle which is 40 degrees, I got to use sine. Okay, so now okay, wait, sorry, I explained wrongly. So I'm not resolving parallel to the plane. Okay, so I explain again. I'm resolving the forces perpendicular to the plane. Okay, that's why I drew this arrow. So when perpendicular to the plane, I only have one, which is the RA. Okay, so now the RA here is basically, you can resolve this as well. So for your information, this is going to be 40, right? This is going to be 40 degrees, which is tally with this. So now I will have two forces. One is due to the weight, another one is due to the RA. So from here, I will get my RA is basically 1.2 G cos 40 degrees. So it will be 1.2, the G is 10 cos 40 degrees. Then you will be getting 12 cos 40 degrees. Okay, I leave it in exact value. Now, when you resolve parallel to the axis or to the plane, so this part, okay, this part will be resolved to the in the same direction as the FRA. Okay, and then here you will have T, the tension. This is tension, this is tension. It's the same string. So from here, I will write my T, okay, the tension here. It will have two components. One is FRA, another one is 1.2 G sine 40 degrees, because the angle, this angle is not given. Alright, so I will write 1.2 G sine 40 degrees plus FRA. So the FRA is basically, this is 1.2, G is 10, sine 40 degrees. The FRA, okay, so for your information, frictional force is mu RA. Okay, and then the mu is given, just remain as mu. The RA we have found, which is 12 cos 40 degrees. Then I will let this be my first equation, that is my T. And now we consider the particle B. Okay, it's the same. So just resolve vertically and perpendicularly and parallel. So now if I resolve perpendicular to the plane first, so which means now, okay, perpendicular means that I need to know this angle. This angle is basically 50 degrees. So RB is basically 1.6 G cos 50 degrees. So here I will just write RB is 1.6 G cos 50 degrees. So this is 1.6, the G is 10 cos 50 degrees. So this is going to be 16 cos 50 degrees. Okay, so the other one, it will be parallel to the plane, right? So now when you resolve, okay, let's see here. I got to resolve this, and for the upwards, right, you will have T, this T together with the FRB. So I will write T plus FRB equals to 1.6 G, and then I resolve to the left side, I mean parallel to the plane, it will be sine. So equals to 1.6 G sine 50 degrees. Okay, then from here, replace the RB first. So T plus mu RB, FRB, so mu R, which is 16 cos 50 degrees, equals to 1.6 times 10 times sine 50 degrees. So that is my second equation. Now I will substitute first equation into second equation because now you need to find mu. I need to eliminate the T. Okay, so you will get 1.2 times 10, so I just rewrite all the terms, sine 40 degrees, plus mu times 12 cos 40 degrees. Okay, that is my T. Then plus mu times 16 cos 50 degrees. Right hand side, just rewrite. So 1.6 times 10 sine 50 degrees. So for the first part, okay, or probably I will just simplify these two terms, those with the mu. So when you add up, you will be getting 19.477135 mu. Then equals to this whole term, you will move it to the right side. So therefore, this is going to be 4.543259.774. I write down the exact value. Then your mu is the division of these two numbers. Then you will be getting the value which is between 0 and 1. And then you will be getting 0.23326. And now you round up the answer correct to 3 significant figures. That will be 0.233. Okay, so that's all for the working of this question. Okay, now next question, number 6. A car of mass 1,300 kg is moving on a straight route A. On the horizontal section of route, the car has constant speed of 30 meters per second, and there is a constant force of 650 newtons resisting the motion. First part, calculate in kilowatt the power developed by the engine of the car. Okay, let's say this is a car. Car must have driving force. Let's say D is driving force. Okay, so then the resisting force is 650 newtons. Alright, so it mentions constant speed. So the V is 30 meter per second. So when constant speed means that the A equals to 0. Now we need to find the power. So before we get the power, we need to get the D first. What's the driving force? So now, okay, so from here we know that power equals to F times V. Alright, before we get the power, we need to get the F. Okay, so probably I start with the Newton's second law, F equals to ma. So now based on this diagram, okay, that is your V. Then the F is basically D minus 650. Then the M is 1,300. Due to the constant speed, the A is 0. Then from here, I know that the driving force is 650. Okay, I will let D be the driving force of the engine. Right? So now, power is F times V. So now the question is power by the engine of the car. That means this is D times V. So I will get 650 times the V, 30. Then at last, you will be getting 19500 watt. And now the question asking for kilowatt. So just divide by 3, by 1000, it will be 19.5 kilowatt. So that is the power. Okay, now part 2. Given that this power is suddenly increased by 9 kilowatt, find the instantaneous acceleration of the car. Okay, so now your new power equals to 19.5 plus 9 kilowatt. So it becomes 28.5 kilowatt. Okay, so now I need to find what is the A. So then my power is F times V. So then 28.5 kilowatt equals to F is a driving force times 30. Okay, then from here I will get my D is 28.5 times 10 power 3 because kilowatt, then this is watt, over 30. That means this is going to be 950 newtons. Right, so now actually I shouldn't write the D here because this is the F, not the driving force yet. This is the F. This is the F. Okay, so now we know that F equals to MA. So now based on previous calculation, okay, so this is a D and this is a F. FR. Okay, I will write FR here. So now, okay, you look at the question carefully. Now, this power is by engine of the car, right? That means now the power of the engine of the car increased by 9 kW. That means now this is supposed to be the power by the engine. Okay, so it should be D. So I make the mistake. So here supposed to be D. Okay, so this is the D. So now the driving force of the engine is 950. And again, there is a frictional force here, right? The resisting force. So that means I will write 950 minus 650 equals to the M. M remains as 1300, then A. So now I will be getting 1300 A. 950 minus 650, it will be 300. So your A is going to be 300 divided by 1300. That is 3 over 13. So you can leave your answer in this fraction or you can just calculate. It will be 0.231 meter per second squared. That is your acceleration. Okay, so now for the part B, on a section of the route inclined at inverse sine 0.08 to the horizontal, the resistance to the motion of the car is this amount. When the speed of the car is v meter per second, the car travels downwards along this section of the route at constant speed with the engine working at 11.5 kilowatt. Find this constant speed. Okay, that means this is the diagram. Let's say here is alpha. So alpha is inverse sine 0.08. That means sine alpha is 0.08. Again, here is the car. Okay, it's mentioned that it's downwards. So this is the V. So the frictional force, it will be 1000 plus 20 V. This is your FR. Okay, and the car is 1300 kilograms. So the weight will be 1300 G. Okay, and at the same time, there will be a driving force. Okay, so from here, it's mentioned that constant speed, which means your A is still 0. Now you need to find out what is this V. Given the power is 11.5 kilowatt. So this is going to be 11.5 times 10 power 3. Then I will be getting 11,500. Okay, so first of all, I need to find out what is my D here. So remember, this is the power of the engine. Alright, so now power is D times V. So I will write 11,500 equals to D times V. So what is my D? My D is 11,500 over V. That's my D. Okay, so using Newton's second law, F equals to ma. So again, this is A equals to 0. So it's just that now you have to resolve. Okay, so then when you resolve this 1300 G towards, which is parallel to the plane, this angle is not given. Therefore, I have to resolve using sine alpha. Okay, so when you resolve, this force will be in the same direction of the D. Okay, and against the FR. FR is different direction. So you will be getting D plus 1300 G sine alpha, because the frictional force or resisting force is the resistance. Okay, the resistance is opposite direction, therefore I minus 1000 plus 200 plus 20 V. Okay, it will be ma. So the m is 1300, the a is 0, because it's mentioned constant speed. So now my d is 11,500 over v, then plus 1300, the g is 10, sine alpha. Okay, sine alpha is given here, which is 0.08. Then now this minus, you move in, you times into the terms inside the bracket. So it will be minus 1000 minus 20V, then equals to 0. Then now from here, I will get 11,500 over V. So the second term is going to be 1040 minus 1000 minus 20V equals to 0. Okay, so rewrite the first term. So the second and third term, when you plus together, it will be plus 40. Then minus 20V equals to 0. Now the question asking for, what is the V? Okay, it's constant speed. So now to solve this, I times the whole equation by V. Then you will be getting 11,500 plus 40V minus 20V squared equals to 0. Now I rearrange these three terms, it will be 20V squared, or I times negative 1. Okay, I times negative 1 first. So I get negative 11,500 minus 40V plus 20V squared equals to 0. Then from here I rearrange 20V squared minus 40V minus 11,500. It will be 0. And now for the whole equation, I will divide by 20. Then I will be getting V squared minus 2V minus 575 equals to 0. And now this quadratic equation can be factorized into V minus 25 and V plus 23. Okay, so your V is either 25 or negative 23. So since it is moving down, okay, so from here, your V is 25 meter per second. Alright, so the V will not be negative 23. Okay. Okay, so done for this question. Now for question 7, a particle moves in the straight line starting from point O before coming to instantaneous rest at point X. At time t seconds after leaving O, given these three different velocities, where the k is a constant, it's given that there is no instantaneous change in velocity at time t equals to 8. Find the distance OX. Okay, first of all, we need to find what is a k. So when t equals to 8, we are given a v, and this is also the v when t equals to 8. So from here, I will just write at t equals to 8, right? The first v, 30.6 minus 0.9t, is equal to the second v, so 1600 over t squared plus kt. So which means now I will replace the t by 8 so that you can find the k value. Okay, so which means 23.4 equals to 25 plus 8k. So 8k equals to negative 0.2. Now, I need to find out what is the time, okay, when it comes to rest. That means at point X, the v equals to 0. So it must be after 8 seconds, right? So v equals to 0, 1600 over t squared plus, okay, sorry, here not yet finished. The k equals to, okay, mistake here. This one, when you simplify, it is negative 0.6. Okay, then your k is negative 0.2. This is 1.6. Okay, so here plus kt. So the k is negative 0.2. Then the t is unknown, and then I will get 0. Now I need to find out what is the time when it comes to rest. Okay, then only I can find the distance. So then from here, you will get, okay, so since you have t squared in the denominator, so I times t squared first to the whole equation, you will be getting 1600 minus 0.2 t cubed equals to 0. So 0.2 t cubed equals to 1600. So your t cubed is 1600 divided by 0.2. That is 8000. Which means your t is cube root of 8000. That is 20. So now I need to find the distance OX. That means we need to do integration for all these t value, all this v with respect to the t. Okay, so it means that at t equals to 20, right, the particle rests. Okay, so now the distance, which is OX, it will be integrate v dt. So now I have to split it into 3 integrations. So the first integration is 7.2 t squared, t from 0 to 2. And then the second distance is from 2 to 8, and this v. Okay, and then the third distance, it is to integrate from 8 until 20, because we have found that when t equals to 20, the particle comes to rest. And then the v expression is 1600 over t squared plus the k is replaced by negative 2, 0.2. So it means that it will be 1600 over t squared minus 0.2 t dt. Okay, so now when you do integration, the first one is going to be 7.2. Integrate t squared, you will be getting t cubed over 3. The limits 0 to 2. Plus, the next integration is 30.6t minus 0.9t squared over 2 from 2 to 8. And then lastly, okay, then plus 1600. This is t degree negative 2. Just for your information, to integrate t degree negative 2 dt, you need to plus 1. So minus 2 plus 1 is minus 1 over minus 1. So this is the integration. Okay, then plus c here. This is for indefinite integral. So then I will get t power negative 1 over negative 1. Then minus 0.2 t squared over 2. 8 to 20. Okay, then now just replace the values. Excuse me. So for the first one, 7.2 over 3 is 2.4. So I will write OX 2.4. Then replace the x by 2, the t by 2 first. So I will get 2 cubed minus 0 cubed. Next value, 30.6 multiplied with 8. Okay, so replace all these values. So now the t is replaced by 2. Then lastly, you get 1600 over minus 1 means minus 1600 over t. Okay, t degree negative 1. So the t is replaced by 20. Then minus 0.2 t squared, t is 20 over 2. There's the value when you replace by upper limit. Then now your minus when it is replaced by lower limit, which is 8. Okay, so from here, when you calculate all these values, you will be getting 2.4 times 8 minus 0 plus 244.8 minus 28.8, then minus 61.2 minus 1.8. That is from the second distance. Okay, and then the third distance, it will be plus negative 80 minus 40, then minus negative 200 minus 6.4. Then from here, you will be getting 19.2 plus 156.6 plus 86.4. Okay, so at last, you will be getting 262.2 meters. So that's the OX. Okay, so we have done for this video. We have done for this paper, and it also comes to the end of the video. Thanks for watching. Please subscribe to the channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.